We want to go deeper into the diagnostics. Talk about the failures. One failure possibility is leaking control valves. Either the holding or isolation valve or the dump valve is leaking. Now, we may or may not get a code on that. But if the valves fail to seal, the ABS will not function properly. The pump may run frequently. But let's show you how we test this. It's actually straightforward. If we have a code or another indication that the vehicle has a problem, we get this simple diagnostic for you. We're going to use a scan tool to activate a specific valve and test its operation. Let's say in this particular example, we're going to keep picking on the right rear valve. We know what each valve should do, so we can do a performance test where we actuate the valve and see if it does what it's supposed to. Now, we can use a scan tool. If you don't have a scan tool, we can do it with a jumper lead. Isolation valve should seal pressure when it's energized. Straightforward. It should block it or it should seal it. Either way, what's there should stay there. A pressure reduction valve should stay sealed until it's energized, so we shouldn't have to do anything to see if it's sealed. We have to determine the wiring of the isolation or holding valve. In this particular case, it's a rare situation that you have to supply B+. So you'd have to take the B+ and put it on the control side because the other side is grounded. We can show you some ways to do that with power probes and stuff. It makes life a lot easier. It could be one that's going to be energized with closing the ground and not the power. Here's such an example. The low side drivers supply ground. This is the common variety. Either way we have to do it. What we're going to do is supply what's needed to energize this valve. If we energize it, we close it. We're going to energize it at a specific time and then check to see if it did its job properly with a simple test procedure. The holding valve is normally open. It's energized to close. We've said that before. Now let's talk about how we use that. The holding or isolation valve has to seal pressure. So we're going to create pressure. How do we do that? The first step is to apply the brakes with the valve open. When we apply the brakes, we're putting pressure on all cylinders. Next, energize the holding valve to seal the pressure on the brakes. If the holding valve seals and the pressure reduction valve is sealed, the wheel will be locked with the brake pedal released because the pressure was trapped by the holding valve and held by the pressure reduction valve. You have everything tested in one simple step. Again, if you don't have a scan tool that does it, use a power probe or a jumper to supply the needed voltage to activate the holding valve. This tells us for sure the problem is inside the electro-hydraulic unit. So one simple thing. All the wheels should be locked by the applied pressure. Here it is visually. We're going to energize the holding valve to seal the pressure on the brakes. We're going to release the brake and check that the right rear wheel remains locked by the trapped pressure. If either the holding or the pressure reduction valve leaks, wheel will not be locked. It's not a serviceable unit, so leaking valves indicate a replacement is necessary. However, there are some rebuilt units available. So to summarize, in one quick session, the hydraulic control unit valves have been diagnosed through dynamic testing. When all of the functions are tested under modified operating conditions, real well pressure. The resistance testing could have been done to detect a bad solenoid or a bad valve actuator, but it would not detect a leaking valve. We've got to ensure that they operate properly under actual operating conditions like we did here. Now it's time to move on to more complex systems that offer features beyond basic ABS. We're also going to take the time to go through some variations where it's not as straightforward as this system we had here, where there's more complications to the control of the pressure.